Keeper 7.2, integration with inverse trig. Alright, so just a reminder of our integrals for inverse trig. We have 1 over 1 plus u squared. That's arctan or tan inverse. 1 over root 1 minus u squared is arcsine or sine inverse. And 1 over u, or sometimes you might see it as absolute value of u, square root of u squared minus 1 is arcsecant or secant inverse. You guys should remember these because these are just your derivatives of your inverse trig functions that we did a while ago. Alright, so here's our first example. We have the integral of dx over square root of 1 minus 4x squared. So immediately when I look at this integral, I feel like it looks like a sine inverse or arcsine. The problem is with your sine inverse, you want it to be 1 minus something squared. And so this 4x squared piece, I need to make it one whole thing squared. And so what I'm going to do is I'm going to rewrite that as the integral of 1 over root 1 minus 2x, all of that squared, dx. And so this 2x, I can check, that is, if I square it, that is the same as 4x squared. But now it's more in the form of my arcsine. And so what I'm going to do is I'm going to do a simple u sub, and I'm going to let u be that inside piece. I'm going to let u be 2x, so that means du over 2 is dx. Alright, and so now if I substitute this back in, I'm going to have 1/2 on the outside of my integral, 1 over square root of 1 minus u squared du. Now this integral looks exactly like my sine inverse, and so I have 1/2 sine inverse of u plus c, but again I don't want that u in there, so I'm going to substitute that u for 2x, and I have 1/2 sine inverse 2x plus c. Alright, so here's another example. In my heart, I feel like it looks like arcsecant. Again, the problem is this 4y squared, I need it to be one whole thing squared. I can't have like 4 and then something squared. It has to be something grouped together squared. And so looking at that, I know just like in the last problem, instead of 4y squared, I can make that 2y all squared. And so I'm going to let u be 2y. And doing that, I know that du is just 2 dy, or du over 2 equals dy. Substituting that back in, I notice that I have an extra y in my problem. So I have to figure out what y is, and y is u over 2. And so now I can actually substitute everything in and get an actual expression. So I have 1/2, and that 1/2 comes from this du over 2. The integral of 1 over u over 2, that was my y, square root of u squared minus 1 du. Now I need to get rid of this over 2 here, so I'm going to keep change, flip it up, and take it out of my integral. And if I do that, I'll be left with the integral of 1 over u, square root of u squared minus 1, which looks like my arcsecant, so I'm left with secant inverse or arcsecant of u plus c. But substituting my u back in, I have secant inverse of 2y plus c. Alright, so this problem looks a little crazy. I would think originally, if I wasn't really good at this, I might have thought that this would have been a regular u sub problem. But the problem is, if this was a regular u sub problem, I would have like a 18x as my du, and I don't have an additional x in my problem, so I can't do a regular u sub. So my next thought is, well, it kind of looks like an arctan. So the catch is I need to make sure that this is actually something squared, like we've been doing. And so instead of 9x squared, I'm going to say that's 3x squared, like 3x in parentheses and squared. And so I'm going to let my u be 3x. And so du is going to be 3 dx, but then I'm going to divide the 3 to the other side. So du over 3 equals dx. And I'm going to pull that out of my integral and substitute everything in. So I have 12 over 3. If I pull the 12 out as well, integral of 1 over 1 plus u squared du. Alright, and then taking that integral and reducing that 12 over 3, I have 4 tan inverse of u, but again, u is 3x, so it's 4 tan inverse of 3x plus c. Alright, so this one is a lot harder. Again, I'm looking at it and I feel like it looks like an arctan. The problem is that with arctan, you can't have this 4 here. This number right here has to be a 1. So what I'm going to do is I'm going to factor out that 4 out of my denominator. But understand, when I factor out this 4, I also have to factor it out from this x minus 3 squared term. And so when I do that, I'm going to have the integral of 1/4, 1 over 1 plus, and then it's really x minus 3 squared over 4. But again, I wanted to make that whole thing squared, so I'm going to do it over 2, all squared. And again, if you were weary about that, you could square this back out and bring that 4 back in, and you should see that you have the same exact expression that you started with. And so now that I have this cleaned up, I'm going to let u be x minus 3 over 2, which means that du equals 1/2 dx. But I don't need that 1/2, so I'm going to multiply it to the other side to get 2 du dx, or equals dx. Alright, now substituting that back in, I get 2 over 4, integral 1 over 1 plus u squared du, which is 1/2 tan inverse of u, or 1/2 tan inverse of x minus 3 over 2 plus c. Alright, so this next one again is a little bit challenging. It doesn't really look like anything familiar. However, I know that if I let u be the square root of x, then the square root of x squared is x. And so when I let u be the square root of x, I know that du is going to be 1 over 2 root x dx, which is all of this dx over 2 root x. And so all I'm left with in this problem is 3 on the outside over 3 times the integral of 1 over 1 plus square root of x squared, which is just x, so that's just u squared. Alright, so then I'm left with 3 times tan inverse of u, or 3 times tan inverse of root x plus c.